In question 1, we're looking for which figures can have a triangle as a cross section. So let me show you the cone first. So for a cone, if I take the cross section that is perpendicular to the base, I will get a triangular cross section. The next one is cylinder. For a cylinder, I'm going to try to tilt this. And so far, I'm shifting it all around and I'm not really seeing a triangle. So I'm thinking maybe we can't get a triangle from a cylinder. I have a cube here and we're going to find the cross sections of the cube. And I'm looking for a triangle. And it took some playing around in a weird angle, but notice how you can get a triangular cross section from a cube. And I can tell that because we can kind of see that in the corners, we can make triangles. And finally, for the square pyramid, I think that one's a little bit obvious. If you take a cross section that is perpendicular to the base, you will get a triangle. So the correct answer to number 1 is everything except choice 2. Over here, we have AD is perpendicular to AE and AD is perpendicular to AB. So we need the plane that's perpendicular to AD. So AD is vertical, so we need a plane that is horizontal and forms a 90-degree angle with it. And that is going to be this plane over here because it forms a 90-degree angle and is perpendicular to AD. Now we only need 3 points in order to name a plane, and that's why it's not called plane EABF with 4 letters, because just like 2 points is enough to name a line, 3 points is enough to name a plane. Over here, we have a right circular cylinder with a diameter, and we are taking a cross section that is perpendicular to the base and passes through the center of the base. So let me just get a visual here so we can see what's going on. So as you can see here, this cross section that I had up before is perpendicular to the base and passes through the center of the base. And notice what shape it is. It is a rectangle, so that knocks out answer choices 1 and 2. If it was parallel to the base, it would be a circle. But since it's perpendicular to the base, it's a rectangle. And notice how, since the diameter was 8, the diameter is the whole side of the cross section. So we're looking for the rectangle that has a side of 8 and a side of 12, which is the height of the cylinder and also the side of the rectangle. So we're looking for 8 and 12. And that brings us to answer choice number 4. Okay. In number 4, we have a pyramid with a square base, and we need to find the volume. Volume of any pyramid is 1/3 capital B times H. Capital B is area of the base. And since the base is a square, we find the area of the base by doing length times width. But since the length and the width of a square are the same, you can think of it as a side times itself, or side squared. And that's how I'm going to write it here because I think that's a little bit easier to understand. Actually, they tell us that the perimeter of the base is 36. So if the perimeter of the base is 36 and there are 4 sides, that means each of the sides have a length of 9. Instead of writing s squared, I can actually substitute in what the side is. And the height is 15. This was all in inches. So our volume is going to be in cubic inches. I'm going to type this into my calculator now. 1/3 9 squared times 15. And I got 405 cubic inches as my answer. The next question is talking about rotating a rectangle around a straight line. If you rotate the rectangle around a straight line, the 3D solid that's going to result is going to be a cylinder. And you can think of a piece of paper. If you fold a piece of paper, it will become a cylinder. Let's try out each of the answer choices and see which one is going to give us a volume of 150 pi. If we rotate around the long side, then that means we're spinning around the long side, and I'm a terrible, terrible artist, but here's our cylinder. So it's a cylinder that's laying on its side. And as you can see here, the radius is 6, and the height is 10. So volume for answer choice 1 would be pi r squared height, because that's a cylinder. The radius is 6. The height is 10. And that would be 360 pi. So that's not the choice we're looking for. Let's try the next answer choice. So in the next answer choice, if we're rotating around one of the short sides, we're rotating this way. So we have our cylinder, and this time our cylinder is right side up. It's just a horrible picture. And as you can see here, our radius is 10, and our height is 6. So for answer choice number 2, I'm going to plug in our radius of 10 and our height of 6, and that's 600 pi, which is not the answer choice we're looking for still. Let's try out the third answer choice. So the third answer choice is around the vertical line of symmetry, and that's mirror images on both sides. Just pretend that this is exactly down the middle over here. So we're rotating around this line that's in the middle. Since it's in the middle, it's not going to look like it's doubling on either side of the line this time. We're spinning around the line, so this is going to be our cylinder. And as you can see, the radius is 5, and the height is 6. And this is a cylinder that's standing upright. So for this one, our radius is 5, and our height is 6. Oops, I wrote 65, 6. So we have 25 times 6, and 25 times 6 is 150. So that is the choice we're looking for, 150 pi. If you try the horizontal line of symmetry, which is this way, you wouldn't get 150 pi, but you can try that one out yourself. If we cut this horizontal prism parallel to the base, oops, I'm a terrible artist here. But if we cut parallel to the base, that's this way, and it's going to be the same as the base. So it's going to be a hexagon. If we cut perpendicular to the base, it's going to be the same as the faces, and it's going to be a rectangle. So once again, if we cut perpendicular to the base, we are going to have a rectangle. Oops. Sorry, this is moving everywhere today. This is true. The prism can have a triangular cross-section because look, we can get a triangle depending on how we slice it. And this is false. Since there aren't any curved parts here of this prism, we're never going to be able to get a circle cross-section. Number 7 and 8 are the same question, so we're only going to do it one time. So a rectangular prism has a base with a length of 25, a width of 9, and a height of 12. A second prism has a square base with a side of 15. If the volumes are equal, what is the height of the second prism? So the volume of the rectangular prism is area of the base times the height. And since the base is a rectangle, that would be length times width times height. So that is 25 times 9 times 12. And that is 2,700 cubic units. So we know that this volume is also the volume for the second prism because they have equal volumes. The volume of the second prism we know is going to be 2,700. It's the same volume as the first one. And area of the base times the height is the volume formula for any prism. And since we have a square prism, the base is a square. So we can find the area of the base by doing side times side. You can think of it as length times width, but all the sides are the same in the square. So I'm going to write it as side times side so that we only have one variable, which is side squared. And we know the side length is 15. And 15 squared is 225. And to get h by itself, we're just going to divide both sides by 225. And we get that the height is 12. Here we have a rectangular tabletop made of maple wood that weighs 43 pounds per cubic foot. There's a mass unit and a volume unit. So this number here is the density. We have some dimensions of the tabletop. Notice how they have different units. 8 feet, 3 feet, 1 inch. Since our volume unit for the density is cubic feet, I ultimately need my volume to be in feet, in cubic feet, in order to use my density. So I'm going to convert the inch to feet so that everything could be in feet, which is where I need it to be. To convert from inches to feet, we're going to divide by 12. So you can go into your calculator and get the decimal, but that is 1/12 of a foot because it's 1 divided by 12. But you can get the decimal. So now I need the volume of the tabletop, which is going to be the length of 8 feet times the width of 3 feet times the thickness of 1/12 of a foot. And since everything is in feet, this volume is going to be in cubic feet. And on my calculator, 8 times 3 times 1/12 is 2. And now I can go over to my density formula, D equals M, which is what I'm looking for because I'm looking for the weight of the tabletop over volume, which we found to be 2 cubic feet. The feet cancel out. So that means our mass is going to be in pounds, which makes sense because that is the mass unit. If it makes it easier, you can stick this over 1, so that way you can think of it as cross multiplication. M is equal to 86 pounds. Moving over to number 10. The volume here, be careful. We need the height. This is the slant height. We need the actual height. If you use the Pythagorean theorem, because this is a right circular cone, so this is a right angle. You should get that the side is 4, the height is 4. So the volume of the cone is 1/3 pi r squared times height. And the volume of the cylinder is pi r squared times height. I'm going to just put the numbers into the calculator for now to see if I can make this simpler. So 1/3 times 3 squared times 4, and that's 12. So this volume here is 12. Oh, I forgot the pi. 12 pi inches cubed. And this volume here is 16 times 6. So this volume here is 96 pi inches cubed. And these are the exact values. So now, if we divide the 96 pi volume over the 12 pi, these cancel out. And what we get is exactly 8 full cones of water. This does come out exactly. But even if you round it, if you put pi into your calculator, you should still get 8. It should be like 8.00000 like 1 or something. It should come out just slightly over 8, but the exact value here is 8. It does work out evenly. Okay. Here we have isosceles triangle ABC. AB is equal to AC. And the altitude is drawn, so we do have right triangles here. The length of AD is 12, and the length of BC is 10. We're forming a solid by rotating continuously around AD. We know a triangle is going to become a cone. And since we're rotating around AD, let me try to draw this cone. So here's my cone. Since we're rotating around AD, so since it rotated around AD, here's AD. And that means since BC was 10, that means the radius is 5 and the height is 12. So the volume of a cone is 1/3 pi r squared height. So the radius is 5. The height is 12. Let's put this into our calculator. And it does say to the nearest cubic centimeter, so I am going to stick the pi into my calculator as well. And I got approximately 314 cubic centimeters. This next one is a little bit tricky. The best approach here is to find the volume of the entire fire pit, to find the volume of the hole, and to subtract so that you can get just the concrete walls. Because the walls are what's made up of concrete, And that's what you're finding about in the question. You're finding the number of bags of concrete needed to build this. So if we take the whole and we subtract off the whole, the inside part, then we'll just be left over with the concrete that we need. So first we're going to find the volume of the whole fire pit. So I'm going to write here, this is the whole fire pit. Should write whole here. Okay. So we can think of volume of any shape as area of the base times the height. Since this is a square-based fire pit, squares have equal sides, and we find the area by doing side times side. So that's side squared, whatever the side of the base is, times the height of the entire fire pit. So the side of the base is 3.5. There we go. Now we can see the measurement, 3.5 feet. And the height is 1.5. Let me put this into my calculator real quick. And I got 18.375 cubic feet. Now, let's find the volume of the whole, the inside part has the fire that's empty, not being made up of concrete. It's just empty except for the fire. So once again, volume of anything is area of the base times the height. And this is a square as well because the fire pit is a square-based fire pit. So this has to be a square as well. So it is the same area formula, which is side squared, because once again, square. So side times side is how you find the area, times the height of the inside part. So the tricky part here is figuring out what one side of this fire pit's going to be. And be careful because this 9 inches is in inches, but everything else was in feet. So before I even get started, I'm going to convert that 9 inches to feet by dividing it by 12. And that is 0.75 of a foot. Or you can leave it as 9 over 12 or 3 over 4 of a foot. So now that is in feet. So this is 9 inches or 0.75 of a foot. And so is this. This is also the same 9 inches or 0.75 of a foot. So this hole over here, this whole segment, oops, I'm very bad at highlighting. This whole segment was 3.5 feet. So this is this, take away these two pieces. So I'm going to take 3.5 and I'm going to subtract the 2.75 of a foot. 0.75 of a foot plus 0.75 of a foot is 1.5 feet, 1.5 feet. So 3.5 minus 1.5 is 2. So a side of this square is 2 feet. So that's going to go here. And then the height of this fire pit is the same throughout. So the height on the inside is the same as the height on the outside because this fire pit is the whole height throughout. So it's once again going to be 1.5 because from the bottom up to where the top is, it's 1.5. It's the same as the rest of the fire pit. It's just empty instead of being filled with concrete, but it's the same height. So that's going to be 1.5 feet. So we have 4 times 1.5, and that is 6, and that's cubic feet. So now we can subtract the entire fire pit minus the empty space inside for the fire, and that's going to give us just the walls that need to be concreted, which is 12.375. And then from here, in the question, you are given the density. Oops, my bad. So we are told that a bag of concrete mix will fill 0.6 cubic feet. So we have 12.375 cubic feet that need to be concreted. So in order to find out how many of these bags will be needed to fill this space with concrete, we can divide 12.375 over zero point 0.6, see approximately how many bags of concrete this is going to take. And I got 20.625, which rounds to approximately 21 bags, because if we got 20 bags, we wouldn't have enough concrete. So we would need 21 bags of concrete. For this one over here, we need to use Cavalieri's principle to explain why the volumes are equal. Cavalieri's principle says if the area of the bases and the heights are the same, the volumes will be equal. That's because volume of any shape is capital B times H, area of the base times the height. I should use the specifics from the question as well. That's why they're there. Both figures have a triangular base. And let me actually find the areas of bases. The area of the space would be 1/2 base times height, and 8 times 5 is 40, divided by 2 is 20. And the area of this base is also 1/2 base times height because it's a triangle. So that's 1/2 base times height. So that would once again be 20. Both figures have a triangular base with an area of 20 square units. Both figures have a height of 14. Therefore, they have the same volume. Last question, number 14. So the side length of both of these containers is the same. That's what it says. Oh, it says both containers contain the same amount of volumes, the same amount of almonds. When we're talking about the amount of something, we're talking about the volume. So that's saying that both of these have the same volume as each other. So let's find the side of the new container. So the old container was the cylinder, and cylinder volume is pi r squared height. The radius is 7, and the height is 18. So that would be 7 squared times 18 882 pi. The new container is a rectangular prism, so that's area of the base times the height. And since it's a rectangular prism, that's length times width times height. And what we do know about it is that its height is 16. Oh, sorry, the rectangular prism has a square base. So the length and the width are going to be the same. So I'm just going to represent that as side squared because it's whatever the side is times itself, side times side. And it tells us that the height is 16. I also know that they have equal volumes. So I know that the volume of this container, and I just need more space, also needs to be 882 pi. Now I'm going to solve for the side. I'm going to divide both sides by 16. So 882 divided by 16. I have 55.125 pi is equal to side squared. And now I just need to take the square root of both sides. And I am going to type pi into my calculator now. And I'm rounding to the nearest tenth. So I'm doing radical 55.125 pi. And I got approximately 13.2 centimeters for the length of the side. Okay. We're arranging the chocolate covered almonds in a single layer, according to part 2. So the height does not matter because they're only going to be in one layer. So you might be thinking of that baseball problem where in order to find the maximum number of baseballs that we could fit in the container, we divided the diameter of the baseball by the length, the width, and the height. But here the height doesn't matter. That's why they actually don't give us the height of the shelf, because we're arranging them in a single layer. So only the length and the width matter. So we're going to do that same process that we did with that baseball question. The dimensions are the shelf are 80 centimeters long and 60 centimeters wide. And that does matter because the length and width of the container is going to determine how many containers can go on that shelf. So I'm going to take the length and I'm going to divide by the length of the almond box. And I'm going to take the width and I'm going to divide by the width of the almond box, which is the same because they're both the same base, they're both 13.2 like we found in part A. And we want the maximum number. So I'm going to round down because, for example, here I got 6.06, but I can't have 0.06 of a box. And if I put 7 boxes, it's not going to fit. So I'm going to round down here. And 60 divided by 13.2. Once again, even though it's 4.54, I'm going to round down because we can't have 0.54 of a box. And if we put 5 boxes, it's not going to fit. 6 times 4 is 24. That's how many can fit lengthwise. That's how many can fit widthwise. So that's how many containers we can have in total on that shelf.